Section 10.7 is about equations of circles. So to start, let x, y represent any point on a circle with center at the origin, which just means at 0, 0, and a radius of r. So looking at the diagram, if our radius is r here in the red, we can find a right triangle here by saying if I'm going to the right x units and up y units, that means our horizontal distance is x and our vertical distance is y. So you could find r, which becomes the hypotenuse of that right triangle, by doing the Pythagorean theorem. So x squared plus y squared would equal r squared. This is the equation of a circle with a radius of r and a center at the origin. So if I told you that the radius is 3 and the center is at the origin 0, 0, all you would have to do to find the equation of the circle is to take x squared plus y squared and set it equal to r squared, which in this case would be 3 squared, so you would just simplify that to just simply 9. On the flip side of that, if I gave you an equation x squared plus y squared equals 16 and said where is the center and what is the radius, you would say, well, the center is at 0, 0 since it's just x squared plus y squared, and the radius would be the square root of what's after the equal sign. So in this case, the square root of 16 is 4. So you'd have a radius of 4 with a center at 0, 0. So being able to go back and forth like that is something you're going to have to do in this section. Let's look at our first example. Number 1, write the equation of the circle shown. So first off, notice that our origin is the center of the circle. So then you know it has to be x squared plus y squared. And we have to set it equal to whatever the radius is squared. So starting here at the origin and counting out 1, 2, 3, 4 units, our r, the radius, is 4. So remember, it's x squared plus y squared equals r squared. So if our radius is 4, 4 squared is 16. So the equation represents this circle is x squared plus y squared equals 16. In a perfect world, all circles would have a center at the origin. However, that's not how the real world works. So next, we'll talk about what happens when your circle does not have a center at the origin. And the one thing you need to keep in mind is that you can find the equation of any circle as long as you know its center and radius, which brings us to our next key concept, the standard equation of a circle. The standard equation of a circle with a center of hk, so the x value is h, the y value is k, and a radius r is x minus h squared plus y minus k squared equals r squared. So what you're going to do is take whatever the x value of the center and subtract it from the x, and take whatever the y value of the center is and subtract it from the y. Otherwise, you still see that x squared plus y squared equals r squared. Thinking back to our standard equation when the center is at the origin, it'd be x minus 0 squared plus y minus 0 squared, which simplifies down to x squared plus y squared like we had before. So again, you just subtract whatever the x value is of the center from x and subtract whatever the y value of the center is from y. Otherwise, it's still x squared plus y squared equals r squared. So if I had a center of 4, negative 2, and a radius of 10, my equation would look like this. X minus 4, since this is the h, squared, plus y, it'd be minus negative 2, so it'd be plus 2, since this is the k, squared, equals r squared, which would be 10 times 10, which is 100. Let's look at another example. So here's example number 2. Write the standard equation of a circle with center at negative 2, 3, and a radius of 3.8. So negative 2 would be like our h value, and 3 would be the k value, and of course r is 3.8. So our equation would look like x minus the h value, so it would be minus negative 2, so it changes to plus 2, and then we square it, plus y minus the k value, so it would be minus 3 squared, and then we need to square the 3.8. So simplified, this would look like x plus 2 squared plus y minus 3 squared equals 14.44. And that would be our final answer for the standard equation of a circle with a center at negative 2, 3, and a radius of 3.8. You also need to be able to work backwards. So let's say if I gave you an equation that looked like this. x minus 9 squared plus y plus 3 squared equals 25, and I want you to find the center and the radius. So knowing that the equation is x minus the h value, that means our h value is just positive 9, not negative 9, and our equation is y minus the k value, so this would be the opposite of the plus 3, so we have negative 3 for the k value, and it's always equal to r squared. So the square root of 25 is 5. So it'd have a radius of 5 and a center at 9, negative 3. So again, being able to go back and forth, whether you're given the center and the radius and come up with the equation, or you're given the equation and you have to come up with the center and the radius, this is something you're going to have to get used to and good at for this section. And now let's look at another example. Here's number 3. The point 8, negative 1 is on a circle with center 4, 2. Write the standard equation of the circle. Now remember, you can always write the standard equation of the circle if you're given the center and the radius. Notice in this problem, we're only given the center, but not the radius. So let's set up our equation based on the fact that the center is at 4, 2, and we'll come back to this point 8, negative 1 in a second. So again, so far we know that the h value is 4 and the k value is 2. So let's write our equation. We would have x minus the h value, which is 4, squared, plus y minus the k value, which is 2 squared, and it's equal to r squared. So again, we don't know what the radius is. However, we have a point here that we can use to plug in for the x and the y in our equation, which would then enable us to find r. So we're going to put 8 in for x and negative 1 in for y. So we would have 8 minus 4 squared plus negative 1 minus 2 squared equals r squared. So 8 minus 4 is 4, 4 squared is 16, plus negative 1 minus 2 is negative 3 squared is 9, and again that's equal to r squared. 16 plus 9 is 25, so r squared is 25, which means that r is 5. However, for our equation, we just really need what r squared is equal to because that's what the standard form of the equation is. So to go back up to our problem, we would replace the r squared here with what r squared is equal to when we found it using the 8, negative 1. So r squared is 25. So my final answer of an equation that goes through 8, negative 1 and has a center at 4, 2 is x minus 4 squared plus y minus 2 squared equals 25. Now let's look at an example of how to graph a circle. So here's example number 4. The equation of a circle is x plus 1 squared plus y minus 3 squared equals 4. Graph the circle. Much like how you have to have the center and the radius to find the equation of the circle, you need the center and the radius to graph the circle. So looking back at our equation, we have x plus 1 squared, so that meant that our h value is actually negative 1, it'd be the opposite. And then our k value is y minus 3, so our k value is positive 3. So that's our center, and we now know that the equation is set equal to r squared. So if 4 is your r squared, then you just do the square root to find the radius. So the radius is 2. So once you find the center and the radius given the equation, first thing you're going to do is graph the center. So if our center is at negative 1, 3, I'm going to go to the left 1 and up 3. And then starting from the center, we're going to use our radius and count over 2, up 2, left 2, and down 2, and put points. So after plotting those 4 points using the radius, then we're just going to draw a nice circle around those 4 points, plotting our circle. So there would be the graph of the circle with the equation x plus 1 squared plus y minus 3 squared equals 4. And that's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.